these boundary lines there indicates everything in here is going to be the solid. Okay, under the pressure going from 0 to some 160 or even higher, as long as the temperature stays right around 0 degrees Celsius, water is going to be in the solid phase. And then this lighter blue area, that's where the water remains in the liquid phase. Okay, so the temperature is going to be above 0 degrees Celsius, and then the pressure can go from a little bit below, or a lot below the regular pressure, normal pressure, 760 millimeter mercury, and then the pressure can increase to some extent. Water will actually remain in the liquid form. Now this region, the white region, represents the gas. So when you look at the phase diagram, it's always solid on the left, liquid on top, gas on the bottom there. And then these lines here, these lines are the boundaries there. And so going from here to here under this condition, pressure and temperature, sublimation occurs. So water normally do not undergo sublimation, but if you manipulate the pressure and the temperature there, you could go from liquid to gas directly without going through the, going from solid to gas, without going through the liquid phase there. Okay, so talking about the critical point versus supercritical fluid there, is the supercritical fluid is where the difference or the boundary between the liquid and gas start to getting blurred when you manipulate the temperature and the pressure there. So these are the things, and supercritical fluid has some applications there. As at some temperature there, the meniscus that separate the liquid and vapor won't actually disappear, and the state basically mingle to form a supercritical fluid where you can't really tell which part is liquid, which part is gas. Okay, so the supercritical fluid, they will have both the properties of gas and liquid state. Okay, and there are different applications in engineering about supercritical fluids there. That's why many of the engineering programs, Chem 101 is one of the prerequisites there. You need to study the chemistry to understand the basic chemistry about the material there when you, before you become engineers there. Okay, so talking about the critical point refers to the temperature required to produce a supercritical fluid. Okay, that's the critical temperature there. And then the pressure at the critical temperature is what we call the critical pressure. Okay, when at or above the critical temperature, the gas will not be able to condense back into the liquid. Okay, and this is where when you have the boundaries start to mix up and start to get blurred. No matter how high the pressure is, when you are above the critical temperature, the gas is simply not condensing back into the liquid and will stay in the supercritical fluid form. Okay, so these are the things, these are the terms that can happen when you manipulate the temperature and the pressure at the same time. When you change the temperature and pressure there, you will have these different physical states. Okay, talking about the triple point water, and again, the darker color represents the solid, liquid, and the gas there. It is possible that you have water in all three states, exist in all three states simultaneously. Okay, we call that point a triple point. There's always a triple point in any phase diagram there. And this is what we're talking about. At the triple point, water can exist in all three phases there. Okay, what are those conditions? What are the conditions for the temperature and the pressure there? Well, the temperature and the pressure for normal boiling point for water, it's 100 degrees Celsius. Normal boiling point refers to 100, the pressure at 1 atm, 760 millimeter mercury. Okay, and then if you lower the temperature to 0 degrees Celsius and keep the pressure at 760 millimeter mercury or 1 atm, the water will freeze up at 0 degrees Celsius. So that's the normal freezing point. And what's the condition for the triple point of water there? If you keep the temperature somewhere close to 0 degrees, slightly above 0 degrees, 0.0098 degrees Celsius, and if you keep the pressure at a fairly low level, 4.58 millimeter mercury, water can exist in all three states, solid, liquid, and gas. So sublimation do occur for water, solid water into gas water, and at the triple point there, you can see the interchange, the phase change between for water molecules in 3 different states there. Okay, so that's pretty much what we want to talk about. Now in chapter 11, again, we have a section in chapter 11 talking about the solids, chemistry of solid, chemical properties of solid there. And again, that's not going to be the things that we want to cover in chapter 11 there. So when you read chapter 11 for Chem 101, focus on the topics discussed in class there, basically the internal forces, the liquid behavior, phase diagram, and all that, the phase changes, phase diagram. And there is, as you can see, very little calculation involved. So mainly it's the conceptual. You have to understand how we define these terms and be able to use the knowledge of internal forces there and make predictions there. So quite a bit of memorization that you have to do. Although you will not be tested on this particular chapter, at least not in large quantity. Maybe there's 1 or 2 questions involved in this particular chapter, not in as detail as we went through there, but this is something that we do want you to know when you take Chem 101. Okay, so it's 10:11 right now, and I probably want to take another 20 minutes to get the chapter 12 started, and then we will finish chapter 12 tomorrow, and we'll wrap up chapter 15 tomorrow. So we will continue this discussion and chapter 12 there. Okay, so we finished talking about the internal forces there, and the next thing we want to take a look at is the property of the liquid there. We want to take a closer look at the solutions there. Now, we've been talking about solutions, and in chapter 4, we're making aqueous solution. We introduced the concept of a molarity there. You know, we're trying to measure. When we introduce the concept of molarity, basically we're trying to determine the concentration of that solution there. Now, solutions will have different properties and behaviors compared to pure solvent. Now, solution is something that you have a solvent like water, you add something in there and to form a solution there. So we will take a look at how solution behaves differently compared to solvent. So that's going to be the focus there. And when you look at chapter 12 there, we're trying to introduce what we call like dissolves like, the basic principle of how things dissolve in one another. Now we're trying to explain why oil is not going to be dissolved mixing with water, while alcohol can be mixed with water. Alcohol, I mean low molecular weight alcohol there. Okay, so in this particular chapter, again, we have a couple learning objectives there. And the first one, we want you to be able to describe solubility. Solubility in terms of intermolecular forces of the solute and the solvent. And the basic principle is like dissolves like. In order for two things that can be dissolving one another, they must have similar type of intermolecular forces, which is related to chapter 11 that we just finished there. Now, preparing the solution in chapter 4, we talked about this. If you have ionic compound, you put it in water, you end up with a solution. Now, the solution is a homogeneous mixture of 2 or more substances in a single phase. It doesn't have to be a liquid. Air is a solution. We talked about it. Okay.